For the understanding and design of new organic semiconductors, ionization potentials and electron affinities are key properties. Since the release of AMS 2021, accurate ionization potentials and electron affinities could be predicted with GW, or the partially self-consistent eigenvalue-only EV-GW. Now in AMS 2022, quasi-particle self-consistent GW has become available, which itself is completely independent of the starting guess and thus offers high accuracy results without the need to find the optimal functional first. Let's have a look at how it works. First we import an azulene molecule from the compound database and symmetrize it. Then we can set the general and GW settings. Most settings can remain on default, except for the functional PBE0 in this case. The base is set, triple zeta double polarized and no frozen core. In the GW panel, I simply tick the checkbox and select qsGW from the self-consistency drop-down menu. Now I can save and run the calculation. Once the calculation is finished, I find the results in the output file. The ionization potential equals the negative of the GW quasi-particle HOMO energy. So in this case, the ionization potential is predicted to be minus 7.324 electron volts, which is an excellent agreement with both experimental and coupled cluster references. If we rerun this calculation using PBE instead of the PBE0 functional, we will receive the same result, while if we try the same trick with the initial G0W0 code, we end up with different results, which illustrates the issue of choosing the right functional in GW calculations. So that's it for today. I hope you liked it, and as usual I will put a link to a step-by-step tutorial and background information into the video description, and am happy to answer comments below the video.